Welcome back to another video. In this video, we are going to be talking about solving trigonometric equations. And so, yes, this video, we're going to talk about solving trigonometric equations, and I'm going to show you some different types of trigonometric equations and the way you want to approach these equations based on the types, okay? So remember, an equation is when you have an equal sign in the problem, and once you have an equal sign, then you're going to want to solve for the angle. In this case, when we're dealing with trigonometry, you're going to want to solve for the angle that makes the statement true. Okay, so we're just going to go through in this video. We're going to work 4 examples, and they're all going to be different types, and I'm going to show you how to approach each type. Okay, so for this first example, we will want to solve 2 sine of theta equal 1. 2 sine of theta plus 1 equals 0. This type of equation is what we call a linear type equation, and that's because our sine theta has no exponent on it. It's just considered one variable. Our one variable is theta. And so we can actually solve for theta by isolating this sine of theta on the side by itself. So I'm just going to start with 2 sine of theta plus 1 equals 0. And the way I isolate sine theta is I move 1 to the other side by subtracting 1 from both sides. And that gives me 2 sine of theta equal to negative 1. Then I divide both sides by 2, and that gives me sine of theta is equal to negative 1/2. So there's 2 ways I could figure out what theta is. I could first take the inverse sine of both sides. I will take the inverse sine of both sides, and that will get rid of the sine. I could plug that in the calculator and see what I get, but I also noticed that 1/2, sine being 1/2, deals with our special angles. So if you think about your unit circle, and think about where is sine 1/2 on the unit circle. And notice here it says over the interval from 0 to 360 degrees. First of all, that lets us know that it wants us to put our answer in degrees. And second of all, that lets us know it only wants us to go around one rotation, okay? So if I go around one rotation, where is sine of theta? Negative 1/2. Well, first of all, sine of theta is 1/2 here at 30 degrees. So remember, that's where sine is 1/2. So that is the reference angle that we will use. Sine is negative in the third and fourth quadrant. So we're going to have an angle here and an angle here that gives us a sine. That gives us a sine of negative 1/2. So to find our reference angle, our angle here, our reference angle 30 degrees is here. So for our first angle, we would do 180 plus 30. Which is 210 degrees. So that's the angle in quadrant 3. And then for our angle in quadrant 4, our reference angle of 30 is here. So we would do 360 minus 30 degrees. And that gives us 330 degrees. And so this gives us the 2 angles that will give us a sine of negative 1/2. And so since we're only going around one rotation, then we are done. And that's our answer. And so you can write it in set notation with the braces, 210 degrees, 330 degrees, and a closed brace, okay? That's a brace. And that would be your answer for that one. So that is how you would solve a trigonometric equation that's linear in form, all right? Let's look at a different type of trigonometric equation. This one, we want to solve tangent square x plus tangent x minus 2 equals 0. Over 0 to 2 pi. So again, this lets us know we're only going to go around one rotation, but this time we're going to put our answer in radian mode. Now this time we have an equation that's quadratic in nature. All right. And the best way to solve an equation that's quadratic in nature is to let or do what we call u substitution. All right. So we're going to let u equal tangent x. If we let u equal tangent x, that means I'm going to replace every tangent x with u. Then I get u squared plus u minus 2 equals 0. And that helps me to see that this is a quadratic equation. And I can solve this quadratic equation for u and then go back and replace u with tangent x. So if I wanted to solve this, then the way I would do it is, one way I could do it is I could use the quadratic formula, or I could also factor. If I factor here, then I would want to take factors of negative 2 that add to 1. So the negative 2 comes from this c right here, and the 1 comes from this coefficient of the u. So 2 numbers that multiply to give me negative 2, but add to give me positive 1 will be 2 and negative 1. 2 times negative 1 is negative 2, and 2 plus negative 1 is 1. So this will factor into u plus 2, u minus 1. Then I will take each of those and set them equal to 0. So this is solving quadratic equations by factoring. I will subtract 2 from both sides and get u is equal to negative 2. And I will add 1 to both sides and get u is equal to 1. Alrighty. So I've solved for u, but I'm not done. Now I have to replace u back with what I let it equal, which was tangent x. So I will say tangent of x is equal to negative 2. And tangent of x is equal to 1. So I'm going to start first of all by solving. So I would need to solve both of these, figure out what angle would give me a tangent of negative 2 and what angle would give me a tangent of 1. Well, I already know that tangent is 1 at 45 degrees. Y'all remember at 45 degrees you have the same x and y coordinate, and so tangent is y over x. If they're the same, you divide it, you get 1. Well, 45 degrees in radians is actually pi over 4. But if we go around one rotation, so if we look at our unit circle again and we go around one rotation, so here the tangent is positive, but also here the tangent is going to be positive in the third quadrant. So this one was pi over 4. If you go here, that's 3 pi over 4. And so here would be 5 pi over 4. So our second answer here would be 5 pi over 4. Those are the two angles in one rotation that will give me a tangent of 1. Alrighty. Now, I don't know what angle will give me a tangent of negative 2, so the best way to solve this one is to do the inverse tangent of both sides. So if I take the inverse tangent of tangent, so if I do the inverse tangent here and the inverse tangent here, then that gives me the inverse tangent and tangent go away. That gives me x is equal to the inverse tangent of negative 2. And so I will plug that in my calculator, but before I plug that in my calculator, I want to make sure that my calculator is in radian mode because of this 0 over 2 pi here. You want to make sure your calculator is in radian mode. So put it in radian mode and then do the inverse tangent of negative 2. And you get x to come out to be approximately negative 1.107148,718. Okay. So that's the first angle. That's the first angle that will give you a tangent of negative 2. So that's negative 1.107. Because that's a negative angle and because it's less than pi over 2, remember pi over 2 is approximately 1.57, then that's going to be somewhere over here in the fourth quadrant. That's going to be this angle here. So theta or x is negative 1.107. So where else is tangent negative? Tangent will also be negative across here in the second quadrant. So that angle will be the reference angle for that. And so the reference angle will be here. And so in order to find what that angle is, we will have to do, because it's in the second quadrant, we would do pi plus that angle or pi minus that angle. So we would do pi minus the 1.107148718, and that will give us our second angle. All right. So you can add pi to it and you get, so add pi to it and you get approximately 2.034443936. And so you actually end up getting 4 answers for this problem. So for x, your 4 answers would be, and I'm just going to round these to the nearest thousand, 3 decimal places out, negative 1.107, 2.034, pi over 4, and 5 pi over 4. And I'm sure they're not in order from least to greatest, but those are the 4 answers that you get for this problem. All right. If you have any questions, don't hesitate to put them in the comments below. If not, let's just keep going. Let's go and do another example. All right, and now for this example, we're going to solve tangent squared theta plus 4 tangent theta plus 2 equals 0. And we want to do it over the interval from 0 to 360. Again, this one is a quadratic equation because it has the square up here. So I'm going to do the u substitution again. Let u equal tangent x. And so when I replace u with tangent x, I get u squared plus 4u plus 2 equals 0. Now, if I try to factor this, I would want to take factors of 2 to add to 4. The only factors of 2 are 2 and 1. And so in order to solve this, I won't be able to factor it. I will have to use the quadratic formula, okay? I don't know if you remember the quadratic formula, but in case you don't, you have to be able to identify the a, which is the coefficient of the u squared, the b, which is the coefficient of the u, and the c, which is the constant term. And then you plug all of that in to the quadratic formula. So normally it's x equal, but in this case it will be u equal. So u equal negative b. And I taught my college algebra class the quadratic formula with a song. X equal negative b plus or minus square root b squared minus 4ac all over 2a. So I don't know if you know the song or not, but either way it goes, you need to know the formula. So it will be negative b, so negative 4, plus or minus the square root of b squared minus 4 times a times c, all of that over 2 times a. And so then once you plug that in, the rest will be just reducing that. So you would get negative 4 plus or minus the square root of 16 minus 8 all over 2. So that would be negative 4 plus or minus the square root of 8 all over 2. Well, the square root of 8 is the same as 4 times 2. So that'll be the square root of 4 times 2, which makes the square root of 4 be able to be pulled out. That's a plus there. And so if you pull out that square root of 4, then you get negative 4 plus or minus 2 square roots of 2 all over 2. And then you can break that apart. That's negative 4 over 2 plus or minus 2 square roots of 2 over 2. Negative 4 divided by 2 is negative 2. And the 2's cancel in this second fraction. And you get negative 2 plus or minus square root of 2. Now that's just what u equal. We're still not done. And that's two different values. That's negative 2 plus square root of 2 and negative 2 minus square root of 2. So what we're going to do is we're going to replace u back with tangent of x, where we let it equal. And we're going to say tangent of x is equal to negative 2 plus the square root of 2. And also tangent of x, I'm going to write it up here, is equal to negative 2 minus the square root of 2. And so now we would need to solve for x for both of those, okay? And so we would need to take the inverse tangent. So for this first one, we would say the x is equal to the inverse tangent of negative 2 plus the square root of 2. And here we would say x is equal to the inverse tangent of negative 2 minus the square root of 2. And we will most definitely have to plug both of these in our calculator. Okay, so when I plug in this first one in the calculator, inverse tangent of negative 2 plus square root of 2, and you can plug this in just like this, negative 2 plus square root of 2, then I get x comes out to be negative 30.36 11934, and that's degrees. And I'm going to come back to that in a minute. And I'm going to go over here and plug this one in the calculator as well. When I plug in the inverse tangent of negative 2 minus the square root of 2, I get x equals negative 73.67505006. All right, just to give y'all a reference point. Okay, so now we have these angles, and so now we have to consider what other angles will give us this inverse tangent, or give us this tangent, and which ones are in this interval, 0 to 360. So first of all, this angle here, negative 30 degrees, is not within that interval, 0 to 360. So in order to get it within that interval, we would need to find a coterminal angle to it. And remember, you find coterminal angles by adding 360. So first of all, I'm going to add 360 to this negative 30.3611934 degrees. So add 360 to that. And if you add 360 to that, you end up getting 329.6388. I'm just going to round it to the nearest thousand, so 0.639 degrees, okay? So that's our first angle right there. That is equivalent to this angle that we got when we put in the inverse tangent. Because remember, the inverse tangent, the range of that is negative pi over 2 to pi over 2. Alrighty. So now we also need to consider where the inverse tangent is negative. So if I was to plug in negative 2 plus the square root of 2, that would give me a negative value. So inverse tangent or tangent is negative in quadrant 4, which is where this angle is, the 329 degrees. But it's also negative in quadrant 2. So in order to find the angle that will give me this same tangent in quadrant 2, I will use this angle as my reference angle. And so in quadrant 2, I would do 180 minus my reference angle to get that angle. So for my second angle down here, I would do 180 minus the 30.3611,934. And when I subtract that, I get 149 point, if I round it to 3 decimal places, it'll be 149.639 degrees. And so that will be my second angle, 149.639 degrees. That's my second angle that comes from this value of tangent right here, negative 2 plus square root of 2. Alrighty. And then up here, notice the angle that I got when I did the inverse tangent is also negative, which is not in this interval. So I would need to find a coterminal angle to this. And the way I would do that is by adding 360 to that number. So I would do, that's the equal sign, negative 73.67505006006 plus 360 degrees. And when I add 360 to that, I get a total of 286.325 if I round it to 3 decimal places. That's a decimal right there. And so that is the coterminal angle to this negative 73 degree angle, okay? And this, if I do negative 2 minus square root of 2, that's also a negative number. And tangent is negative in quadrant 3, which is where this 286 degree angle is. But there's also an angle in quadrant 2 that'll give me this same tangent value. So again, to find that angle in quadrant 2, I would do 180 minus this reference angle, or you can say 180 plus this angle since it's negative. Either way it go, I need to do 180 minus this 73.675050006. And if I do 180 minus that angle, I get a total of 106.324 or 325 degrees. And so that gives me my fourth angle that satisfies this equation. Okay, so there are 4 angles that satisfy this equation. They are approximately 286 degrees, approximately 106 degrees, approximately 149 degrees, and approximately 329 degrees. And I'm saying approximately because, of course, it's more digits, and that's not even a fully rounded version, but it's close to that number, okay? So these would be your 4 answers, and that is how you would solve that equation. So this is an equation where you use the quadratic formula to solve it. It's quadratic in nature, but it can't be factored. All right, if you have any questions about what I did to solve this problem, put it in the comments below and I will respond. All righty. Let's look at one last example. Example 4. We want to solve tangent of x plus the square root of 3 equals secant of x. Now this problem, it almost looks linear in nature, but the thing that throws us off is that we have 2 different trigonometric functions. Anytime you have more than one trigonometric functions, you're going to want to try to use your identities to convert one of the identities over so that you only have one trigonometric identity in that equation so that you can solve it. So I either need to convert this so that it's only tangent in the problem, or I need to convert it so that it's only secant in the problem. When I think about the trigonometric identities, there is a trigonometric identity that has both tangent and secant in it. and that is the Pythagorean identity. There's a Pythagorean identity that says 1 plus secant or 1 plus tangent square x equals secant square x. Y'all remember that identity? 1 plus tangent square x equals secant square x. And so I'm going to aim to use that. In order to use it, I need to get some squares in here. So what I'm going to do is I'm going to square both sides of this equation. And when I square this left side, that ends up being tangent of x plus the square root of 3 times tangent of x plus the square root of 3. And that equals secant square x, okay? Now, that means I have to multiply this out. So that's going to be tangent x times tangent x, which is tangent square x. And then that's going to be tangent of x times square root of 3. That's going to be square root of 3 tangent x. Also, I will do square root of 3 times tangent of x, which will be another square root of 3 tangent x. So that gives me 2 square roots of 3 tangent x, because I have 2 of those. And then I would do square root of 3 times square root of 3, which would be 3. And all of that would be equal to secant square x, okay? Now, what I want to do is I would want to replace secant square x with tangent square x plus 1 because I want to write this so that there's only tangents in the problem. So if I do that, I'll rewrite this as tangent square x plus 2 square roots of 3 tangent x plus 3, and that equals 1 plus tangent square x. And that's by the Pythagorean identity. So I'm replacing secant square x to 1 plus tangent square x, and it's by the Pythagorean identity. And then I'm going to move everything to one side because I see that this is quadratic in nature because of the squares on the tangent. So I want to get 0 on one side. So I'm going to subtract 1 from both sides, which it will subtract from that 3. And then I'm going to subtract tangent square x from both sides. Now when I do that, I end up getting 0 on the right side of the equation. But the tangent square x is canceled, and I get 2 square roots of 3 tangent of x to drop down. And then 3 minus 1 is 2. So what was actually quadratic has now reduced down to something that's linear in nature. And so I can now solve this by isolating the tangent of x. So I'm going to subtract 2 from both sides. That gives me 2 square roots of 3 tangent x equal negative 2. Then I'm going to divide both sides by 2 square roots of 3 in order to get tangent by itself. Those 2's would cancel. Here, the 2 square roots of 3's would cancel. That will give me tangent of x on the left side. And negative 1 over the square root of 3. Which I don't know it to look like that because we can't leave a square root in the denominator. So I'm going to multiply top and bottom by square root of 3. And that ends up being negative square root of 3 over 3. Okay. And we know that from our special angles that the tangent is square root of 3 over 3 at 30 degrees. Okay. So at 30 degrees, that's one of our special angles. The tangent is square root of 3 over 3. However, we want to know where is it negative. So if we look at our unit circle, tangent is negative in quadrant 4. Oh, in quadrant 4, but also in quadrant 2. So it's going to be here and here. And our reference angle, remember the reference angle is from the x-axis, is 30 degrees here. Our reference angle here is 30 degrees. So if I want to find those two angles that give me tangent to be negative square root of 3 over 3, then I would have to do, for quadrant 2, I would do 180 minus 30, which is 150 degrees. And for quadrant 4, I would do 360 minus 30, which is 330 degrees. So our two angles for x would be 330 degrees and 150 degrees. And so you could write those in set notation, 150 and 330 degrees. All right, and so that is how you would solve that problem. Oh, matter of fact, I did that in degrees, but it asked for radians, so you could just convert those over to radians. So 150 in radians is 5 power over 6, and 330 is 11 power over 6. So you will have to write your answers in radians because it gives this interval in radians right here, okay? That's how you would solve that. So if you have more than one trigonometric function, you want to try to manipulate the equation so that you can rewrite one of the functions in terms of the other one, so that you only have one trigonometric function in the equation in order to solve it. Alrighty. If you have any questions about what we did in any of these trigonometric equations, again, don't hesitate to put them in the comments below. If you understood everything and it was helpful, hit that like button for me. And if you haven't already, go ahead and subscribe to the channel. Thank you all for watching, and I will see you in the next video.